Hello Math 1100 students. We're now beginning Chapter 6 of our textbook. According to my syllabus, this falls in the middle of week 11, so this is lesson 11b. Did I say middle of week 11? Actually, first 1/4 of week 11. Compared with lesson 11a, this one is far more important and far longer too. Okay, here we go. Composite functions. What is a composite function? Let's begin with a pair of functions. G defined from x to y, f defined from set y to z. And now we define a composite function f circle g or f composition g like this. F composition g sends element x, small x from capital X, to small z, which belongs to capital Z. So element from here all the way up to element there. In this way, from G, x goes to y, and then through f, y goes to z. So x goes to y, and the same y goes to z. Here's a graphical explanation. From x, we go to y via g, and from the same y, we go to z via f. Okay? First one, g, x to y, that's highlighted in red. And second one here, y to z, that one's now highlighted in blue. I wish this were highlighted in red, color red, and then this were highlighted in color blue. Okay, red and then blue. I got this picture from my textbook, so I didn't draw it myself. If I did draw, then probably I used the color coding. Anyway, x to y, and then y to z, g first, and then f. Now, if I start from this x to y, and then nowhere to go, that's because y does not belong to the domain of f. This can happen. So domain of the composite function f circle g is usually smaller than the domain of g. Sometimes they are the same, but sometimes they are significantly small. Algebraically, the inside g that is going x to y is the inside function. Let's get this diagram, and then remember this diagram. In this diagram, g first and then f later, right? This one comes first, and go to this parenthesis, inside first. Inside of the parenthesis first, when you have multiple parentheses. That's the usual rule of algebra. Same thing's taking place. G first, inside first, and then the outside. Okay, we went through a lot of theory. Let's do some computation. Otherwise, this concept may be still hazy to you. So let's go ahead with some computation here. Here's a nice problem. F of x and g of x are given like this, and find out the composite function f circle g, f composition g. So basically we are looking for f circle g of x, which is f of g of x. And inside first. You see, inside first. Inside first. Okay, what's the inside? G is 2 minus 3x. So this is f of 2 minus 3x. Okay, so far so good. And now calculate f of 2 minus 3x. F of x is 2x squared, 2x squared minus x. So in place of these two x expressions, we substitute 2 minus 3x. So 2 minus 3x goes here in the left-hand side. I have to do the same thing in the right-hand side, here and there. So this is 2 times 2 minus 3x squared minus 2 minus 3x. Let's keep up with color coding. Red. And then red. Here we go. That's the composite function. This kind of technique is called substitution. So in f of x, this x is substituted by the expression of g, because that's inside here. Substitution probably is one of the most important concepts in mathematics, if not the most important. And we go through this in rigorous detail in elementary algebra and also in intermediate algebra. So a lot of students by now are bored to death. In that case, you can just fast forward. I'm assuming not everybody is totally comfortable here. Alright, as for this problem is concerned, and as for human grader is concerned, this is complete. This is full credit. However, if MyMathLab is grading, then it's going to ask you to simplify further. That is, break up this complete square, break up all the parentheses, take all the like terms together and arrange this resulting polynomial in descending order. Cumbersome step, but let's go ahead and do that. So here we go. We just completed this, which should have been full credit. If I'm grading it, full credit. But let's suppose you are doing this for MyMathLab. In that case, you have to break up the parentheses, complete square, and then break up further, and then take the like terms together, and we have to get to that. Cumbersome, yes, but it is necessary to deal with all those MyMathLab exercise problems. Good news is you can stop here if you're doing an exam problem, because I'm going to be the one who's grading exam. Okay, we did one problem and there are 4 more. So please stop the playback and try some of those on your own. Okay, all right. Let's see, how about the second problem here? I hope everybody tried it already. So composite function is basically f of g of x, and g of x here in this case is 4 over x minus 1. So this is f of 4 over x minus 1. Does it make sense? Now what is f of x? F of x is 1 over x plus 2. But in place of this x, what do we have here? We have 4 over x minus 1, because that's g. Make sense? So in this expression, 1 over x plus 2, this blue x is going to be replaced, substituted by this blue expression. So previously 1 over x plus 2, but this expression here is substituted into this, 4 over x minus 1. So I have to do the same in the right hand side as well. And keep the same color here. And let me increase the font. There goes the solution. And that is the full solution as far as I'm concerned. But let's suppose you have to satisfy MyMathLab or some AI grader. In that case, you're going to need something like this. Okay, all done, but some further simplification is in order. Multiply the denominator of denominator, x minus 1, to each term. We have x minus 1 here, we have x minus 1 there. Here we lose x minus 1, so we have this expression. And then break up the parentheses and take the like terms together. You're going to get the final expression. The detail is left to the students. We have many more here. And I'll just leave those 2 students. Okay, all right, 3 more, but I'm going to leave them all to students. And if you're really comfortable and really bored, then you can skip those. But if you are a little bit hazy on anything, then it's going to be a good idea to repeat this drill so that you get absolutely comfortable. Now let's go to the next topic here, values of composite functions. These are the same functions as before. So why don't we just get this expression from the previous problem and plug in x equals to 1? Or plug in x equal to -2. I can do all those, yes, that's fine. But if you didn't do those already, then it's going to be a lot easier just to use numbers rather than going through all those mathematical detail of these the composite functions and so on and so forth. It's going to be easier to do it this way. So what is g of 1? Because you see, inside first. This time I use red, blue, so okay, green. G is 2 minus 3x, so this is 2 minus 3 of 1. So that is f of minus 1. Okay, what is f of minus 1? I can plug it in here. So that is 2 minus 1 squared minus of minus 1. That is, what is it? 2 plus 1, that's 3. So you can calculate like this. It's going to be easier this way, using numbers, rather than finishing this computation all the way like this, and then plug in x equals to 1 here in the final expression. Either way, you're going to get the same thing, but it's more cumbersome this way. It's easier this way. Okay, we did one problem. Why don't you try some more here? Stop the playback and try more. Everybody tried? Here's the next problem. The usual inside first. F composition g of -2, that is f of g of -2. Let me use different color this time, brown, okay. And what is g of -2? From this definition of g of -2 is this. 4 over -2 minus 1, so it simplifies into -4/3. And plug in -4/3 into this expression here and do your computation. 1 over -4/3 plus 2. Simplify, you're going to get 3/2. You can use calculator if you want to. Okay, a little bit more time, so let's do this one. As usual, inside first, f of -1. And that turns out to be this, because this is definition of f. And then that value is 1. So we end up with g of 1. But what is g of 1? We get 0 in denominator, so this is undefined. See all this? And this is commonplace for composite functions. Out of nowhere, you're going to get some undefined value. Be prepared. This happens. This happens relatively often, as a matter of fact. So nothing's wrong here for getting undefined value or no value. Basically, this kind of thing took place. X to y, and this y is outside the domain of the next function. So stop. Undefined. That just took place. Okay, so much for first two examples. We're going to talk about domain and range in the next video. See you soon.